Hope they can see this. Anyway, yes. When they realize that increasing memory size, putting more process into memory will increase the CPU utilization. So they will try to find a way to just divide the memories. I mean, to put different processes, we have to divide the memory, not physically, but logically. Okay, so this is called partition. I mean, we are also using it in our computer systems. We have, for example, in our hard disk, you can divide it to several partitions. So hard disk can be, if you see, C and D drive, but you have one physical hard drive, but when you make partition divided by two, you will have two logically different hard disk. So the similar thing is they started to do for memories. This is called fixed partitioning. So the easiest and one of the simplest technique which can be used to load more than one process into the main memory is fixed partitioning or contiguous memory allocation. Okay, what is fixed partitioning? We can, in fixed partition, our partition sizes are constant. I mean, when I created a partition, I can erase it. So, as you see, this is the memory. This part is my memory. And, as an extra information, in the beginning of the memory, I told you previously, when you open your computer first, the first thing is the computer does is loading your memory into RAM. Yes. So to just separate from the others, operating system has a reserved space, not reserved, but it is always locating in the beginning, starting from the beginning of the memory. So that's why the beginning of the memory is starting from operating system. We are not interested, but as an extra information, I gave it to you. Okay, so we have four processes need to come load into the memory. And let's say we have four partitions. Okay, we have four partitions. Each of them is totally 4 megabytes. So my memory size is, I mean, just if I don't count the operating system, my memory size is 16 megabytes. And I divide it by 4, each of them. 4 megabytes of partition. So I have 4 partitions. When I put process P1, it will just take the 3 megabytes of space and 1 megabyte will be empty in this partition. And for this one as well, 3 megabytes space it will waste and 1 megabyte empty, and for the others as well. Okay, so in next slides it is explaining, so I am going to. So in this technique, the main memory is divided into partitions or of equal or different sizes. So I can make it, for example, 4 megabytes, 6 megabyte, and 10 megabyte, for example, different partitions. it depends on the system. Okay, so it does not need to be always same how can megabyte of partitions. It can be different, but the main thing is it is let me to continue from the text. The image is explaining everything, but I want to continue from text. As I told you, the operating system always resides in the first partition, while the other partitions can be used to store user processes. So the memory is assigned to the process in contiguous way. So this means we can't change the size of the partitions. So in fixed partitioning, the partitions cannot overlap. So it cannot be over the other one. So it will continue from one after the other. So I can't say, for example, this partition is first partition is have only 3 megabytes and 1 megabyte empty space. I have to use all 4 megabytes. Okay. Okay. So it will say the internal fragmentation, but let me to explain. So using this technique is simple, but so many disadvantages. So first of all, there are a lot of fragmentation. So what is fragmentation here? The unused places. Look, the fragmentation of each partition means the empty parts. It's called internal fragmentation. So if this is 3 megabytes and 1 megabyte of empty space. So this is filled by process 1, 3 megabyte, and we have 1 megabyte of empty space. So the internal fragmentation of partition 1 is 1 megabyte. So if this partition size is 5 megabytes, let's say, so we have to have 2 megabytes empty space. And try to say, let's say, this is my memory, and here process 1 is coming. Okay, it is 3 megabytes, and partition 1 size is 5 megabytes. So it will fill this 3 megabytes, process 1, and we have 2 megabytes empty space. So internal fragmentation of partition 1 will be 2 megabytes. Okay. So the empty spaces of each partition is called internal fragmentation. And external fragmentation is total unused space. So in each memory, in each partition, we have 1 megabyte of empty space. So external fragmentation will be what? 4 megabytes. Let me to give an example. Okay, let's say, forget about the operating system. Let's say I have 3 partitions. partition 1, partition 2, partition 3, let's say. This is 8 megabytes. This is 6 megabytes. I said that they can be different size. That's why I am writing like this. Let's say here I put process 3, which it is 4 megabytes. Let's say I put process 2, which is 4 megabytes again. I put here process 1. Let's say this is 6 megabytes. Oh. So when I put here process 1, I have 6 megabytes full space and 2 megabytes of empty space. Here it is 6. Yeah. So again 4 megabytes full and 2 megabytes of empty space. This one is full. So if I ask you internal fragmentation, will be 2 plus 2. In internal fragmentation, you are not adding them. You are saying one by one. So internal fragmentation of P1 is, you will say 2 megabytes. P2 is 2 megabytes. P3 is 0. Nothing. Okay? No internal fragmentation for this one. For the external fragmentation, you are going to add P1 plus P2 plus P3. I mean, I'm talking about the fragmentation. So let me do it like that. 2 plus 2 plus 0. So it will be 4 megabytes. Okay.
So in the internal, we just have to say what is the empty.
For one specific process fragmentation. So one by one. Okay. Yes.
Yes. Is the partitioning of the memory sizes have a direct order, or if we are going to partition your memory?
1 second. Can you ask me again? I was trying to do something.
Yes, I said, as per the memory size, like P1, we have 8 megabytes. So if I want to partition P1, it left with me which order I want to use, or you have a direct order?
No, I mean, you can select which partition it will go.
All right. Yeah. My second question, for the fragmentation. So what happens to the unused spaces?
Okay, they are staying unused. I'm going to come to that. This is one of the disadvantage of fixed partitioning. This is very old technique, and they will develop it and make very most better techniques that you can make memory more flexible. This is not this is a kind of constant, so you can't change that. So if you put there, for example, partition 1, you will lose that 2 megabytes. Okay, so you can't use whole memory in this effectively. Okay, let me to continue and you will understand. So here actually the point is here. How much megabytes we have? 4 megabytes of empty space. But let's say if process 5 comes with 4 megabytes, it cannot fit any of the partition, because there is not such mechanism that it can divide and put it separately for fixed partition. Okay, so because of it is not contiguous. Sorry, because of we don't have enough. We have enough space, but we don't have a whole space to fit 4 megabytes process 5. We can put any memory there.
I want to know. So for things that you have or a direct order, like every one of them have to be like the partition have to be the same. For this partition, like those have process 5 have 4 megabytes. And because for the process 5 have 4 megabytes, there is no space to go 4 megabytes. So I want to know, so for this partition, the partition have a direct or like they have to follow the same format, like the partition have to be TD3. Like you see process 1 with partition 1 is steady, partition 2 is steady, partition 3 is steady, and partition 4 is steady. So for this partition, everything have to have the same format.
No, because
I didn't understand.
he is asking about this one. If you are doing the partition, you see this one we made 3 and 1. Here we made 6 megabyte, 2 megabyte.
Okay, just we are giving examples actually. So in the beginning, it is given the partitions, and according to that partitions, operating system try to fit the processes into it. Okay, let me to continue, and after that you will better understand. I mean, you can change the partition sizes. Operating system can decide, but when it is changed once, it should just use for all kinds of processes, same partition. This is not so practical, that's why. Also, we are going to, okay. So, the cons of fixed partitioning, the internal fragmentation. So if the size of the process is lesser than the total size of the partition, then some side of the partition gets wasted and remain unused. So this is one stage of the memory and called internal fragmentation. So these places are wasted. So once you put this process, the others cannot be used. So think about that. If you have 16 megabytes of memory and 4 megabytes are still free, but you can't use it. Means 75%, 25% of your memory, you can't use it. So this is one of the disadvantage, internal fragmentation. Okay.
So, like this participation one that has 1 MB left, we can use that one.
No, in fixed partitioning you can't. So if there
only
is,
3.
huh?
It is only 3.
Yes.
But if the 3 is the full, that means no nothing left. We can use her.
Can you tell me again?
If the 3 is full without the 1, that means we can use it.
You mean if the partition size is 3 megabytes?
Yes.
Like this file.
Yes,
Process 5.
of course.
4 megabyte.
Yes, there. Yes, it is. That's why I put that example. You can have, for example, 4 megabytes of partition, and you can put 4 megabyte of process inside it. So you will not have any internal fragmentation in this case, because you use all capacity of that partition.
But when this one is greater, when the process size, the process take maybe like this one, if we have a process that need 5 megabytes.
I understand. For example, for this one,
yeah,
one process comes with 5 megabytes.
Yeah.
So it will not fit anywhere.
It will not fit.
Yes, but
what will happen?
Nothing. But most probably, operating system will was thinking about that and just the thinking while it is making the partitions. It is just putting the maximum size, most probably. So do not need to think in so much detail. But yes, if it is if something like that happens, it will not fit.
So
No chance.
normally we just have this one or three the partition like this, or it's take full. We have internal fragmentation or we have full.
In our computers.
Yeah.
This is very old technology. You will see what they did after that. This is the first technology that they used for multi-programming. Okay? So, and think about that. The previous version was they can put only one process. So they can put a few processes now first. So do not compare it from nowadays technology. Okay. So also the other disadvantage is external fragmentation. So external fragmentation is the total unused space. So the total unused space of various partitions cannot be used to load the processes, even though there is space available, but not in the contiguous form. So what does this mean? Think about that. You have hotel rooms, but for 2-person, 3-person, like that. And totally, you have, for example, 10 empty space, but each of them is, for example, only one person is staying in 2-person room, or one person is staying in 3-person room. So you can't put the other guy there. So the rest of the memory will be wasted. So the total wasted memory is called external fragmentation. Okay? So this is the difference between internal and external. So previous years from these topics, I asked a few questions. And they are very easy. If you know it, you can easily answer. Okay. So yes, this is the answer of your question. Limitation on the size of the process. So if the process size is larger than the size of maximum size partition, I think this is if that time they were designing it, I think this is not happens so much. But if it is happens, if the process size is larger than the size of maximum size partition, then that process cannot be loaded into the memory. What does this mean? Let's say we have another partition here. Another partition that says, say it is 3 megabytes. And four megabytes of process tries to enter inside, so it cannot go inside because the partition size is less than the process size. Okay.
So
Huh.
the megabyte is lower than the part 4. I think the part 4 is 4 MB before, right? 4 megabyte.
Okay, process size is 4 megabytes.
Yes.
The partition size is 3 megabytes. So no, P4 cannot enter inside partition 4 because this size is bigger than the partition size. That's why.
It will stay outside.
Huh?
It will stay outside.
Yes, but yes, but I think the operating system is arranging that. I don't think that there is how can I say? Most probably they know approximate the size of the processes, maximum size. So they are arranging the size according to that in the beginning. But if not, if it happens, it will, yes, it cannot fit inside. It will be outside. And it cannot, it can be never executed. Okay. So here another disadvantage, degree of multiprogramming is less. Why it is less? Because of we can't use the whole capacity every time of the memory. It is decreasing the degree of multiprogramming. So if think about that in this example, if our architecture is a kind of flexible, like maybe it is letting us to put this process just by dividing one by one, which we can do it today. So each part of process one can be put to chocolate. If the system let us to do it like that, or maybe if we can just make a kind of defragmentation and we can separate the full spaces with empty spaces and we can put the process 5. So in this kind of situation, instead of putting 4 processes, we can put 5 processes. So if we put more processes to the system, our degree of multiprogramming will be increased and CPU utilization will increase. Let me to just draw you. I'm trying to say think about that our system is not fixed partition and it is something else. Okay, so when I have 3 megabyte of partition in partition 1, let's say it is 3 megabytes, and let's say we put all the partitions, I mean partition 1, partition 2, partition 3, and partition 4, just separate spaces. And we put the empty space, I mean 4 megabytes, separate space. So let's say we have a technology like that and we put all the partitions here, we separate them. And here I put, I have 4 megabytes of empty space now. So I can put process 5 inside, yes? So previously I can put how many processes? 4. Now I can put 5. So degree of multiprogramming is increasing. And also utilization of the CPU will increase. So it will affect also utilization of the CPU. So they want to solve it because of this reason. So I hope you understood why it is affecting the degree of multiprogramming. So same memory, we can put more process. Okay. So to fix this, they just develop another kind of partitioning, dynamic partitioning. So it is the aim is to try to overcome the problems caused by fixed partitioning. So in dynamic partitioning, in the fixed partition, operating system is arranging the partitions in the beginning. Just it is arranging empty part like this one. In the beginning, it is arranging empty partitions. Okay. But in dynamic partition, it is arranging the partition according to the process size. So it is just a fit to the process. Let's check it. That's why, as you see, the process size is 5 megabytes. Partition size is 5 megabytes. Process 2 size is 2 megabytes. Partition 2 size is 2 megabytes. So it is creating the partitions according to the process size. So in this partition, in this technique, the partition size is not declared initially. It is like I mean, who in PHP, I think, in C++, this kind of languages, when you declare a variable, the operating system will reserve you a space. For example, if it is integer, 4 megabytes of space. But in PHP, for example, you just write the variable value, okay? For example, 3. So the system will think that, okay, this should be an integer. So it will arrange an integer. If you put 3.5, it says, okay, it should be float. It will arrange a float. So it is arranging dynamically. You don't need to, no, you are not declaring, just you are giving the variable names and values. In PHP, for example, there are some other languages. So in this, it is similar. Okay, in the beginning, it is not initially declaring the partitions, creating the partitions. According to the process size, it is just creating the partition as same size. Okay, so it is declared at the time of process loading. So when it is process load, it is declared the partition. Okay, so the first partition is reserved for the operating system as usual. The remaining space is divided into parts. So let me to continue. And the size of each partition will be equal to the size of the process. In this case, I may ask you a question. For example, what is the internal fragmentation of each process, each partition?
Internal fragmentation for each of them.
Uh-huh.
First, process 1, we have
Why?
0 internal fragmentation.
So internal fragmentation is 0 because we are creating according to the size of the, yes.
All dynamic.
In dynamic, internal, yes.
Partition. All
Yes.
internal fragmentation will be
Yes. Internal fragmentation is always 0.
okay.
Okay. So let me to continue. So we can avoid internal fragmentation. Or if I ask, you can say that it is 0. So advantages of dynamic partitioning over fixed partitioning. So they have no internal fragmentation first. So the partitions in dynamic partitioning are created according to the needs of the process. So we don't have any internal fragmentation. As you see, the process size and the partition size are same.
This one is good.
Yes, but it has some other disadvantage, and they will develop another one. But it is just not like, okay, they first created cars, and the first cars and the nowadays cars are basically similar, same. They have four wheels or engine, so brake, everything. Here it is similar. It is when they first made it, they just put a few different things and make it better. So in fixed partitioning, the advantage of dynamic partitioning over fixed partitioning, no limitation on the size of the process. So here, the process size can be big as, how can I say, just you can subtract the operating system size. One process can fit the rest of the memory itself. I'm trying to say, let's say, just forget about all these processes. How much space we have? 5, 2, 3, on the 14 megabytes. Oh. So think about that. No processes came, no partitions yet. We can put 14 megabytes of process alone. Okay. I mean, only one process can fit with 14 megabytes memory.
But even if it is in multi-programming, if one process comes with 14 megabytes, it's going directly inside the memory.
Yes, because multi-programming means it has a capability of store more than one process. Yes, but one process may fit all memory. It is not happening nowadays, but it is possible. Okay, so no limitation on the size of the process. Degree of multiprogramming is dynamic. So due to absence of internal fragmentation, there will not be any unused space in the partition. Hence, more processes can be loaded in the memory at the same time. So if I ask you same memory with fixed partition and with dynamic partition, and in fixed partition 5 processes can fit, in dynamic partition 6. This is because of dynamic partition can just create the partitions when they come. So more process can fit inside same memory. Okay. So external fragmentation is still can be, because we can okay, let me take it. So we don't have internal fragmentation, but we have external fragmentation. Why? Who can tell me?
Because in dynamic partition, the only the operating system only assign the size of the process size. What we have, we take this one. No more unused memory.
But we have external fragmentation, I am saying.
Yes, but not internal.
Yes, but why we have the external fragmentation?
Because the process may come with less size of memory than the CPU.
CPU? Why CPU? Okay, let's say, so we can't have internal fragmentation. Let's make an example for dynamic partition. Process 1 comes, for example, let's say 3 megabytes. And let's say the total size is 20 megabytes. Process 1 comes, so I will put here partition 1. Let's say partition 1. Okay, so this will be 3 megabytes. Then process 2 comes, let's say 6 megabytes. So it will create a 6 megabyte of partition. Of course, this is dynamic partition. So we have still 11 megabytes of space. Let's say process 3 came, let's say 10 megabytes. So it will fit here. So if any process comes, for example, P4, it's 4 megabytes, it cannot fit, it should wait. Okay, so, or if no other processes comes, we have still some empty space. So this is the external fragmentation.
What about the one remaining?
Okay, this is external fragmentation. Sometimes it does not mean that all the processes comes according to your needs. So you have 1 megabyte empty space, but 4 megabyte of process comes, or no process comes. So 1 megabyte of empty space is unused. So this means this is external fragmentation. So in dynamic partition, internal fragmentation, we don't have internal fragmentation, but we may have still external fragmentation. So, I mean, at the end of the memory, you may have still some unused space. I'm trying to say that. So, okay, so also there is another example because look, in computers, it is not like doing only one time. These processes will finish their task, then another process will come. So this is a continuous task. So let's try to do this example to show also the external fragmentation. Let me draw to you for better understanding. Okay, we have 3 processes. P1, 1 megabyte. P2, 3 megabyte. And P3, 1 megabyte. Okay. Are being loaded in the respective partitions of the main memory. So let's say if you put one of them here, the other one here, and this one here. For dynamic partition. Let me continue. Okay, after some time, P1 and P3 got completed and their assigned space is free. So, so this one and this one is, let me also just they were using. But after a while, they are just deallocated. So these places are free. I mean, 1 megabyte and 1 megabyte. Now there are two unused partitions and available in the main memory, but they cannot be used to load a 2 megabyte process in the memory because they are not contiguously located. It means it is not one after the other. They are not in the same place. So the rule in dynamic partitioning says that the process must be continuously present in the main memory to get executed. So because of this rule, now we have two empty spaces. So we can put there a 2 megabyte of process. After we created once, we can put. So this is one of the disadvantages of dynamic partitioning. Did you understand what happened?
If there is one process between two empty processes.
Yes, because of, yes, exactly. Because of they are not contiguous, so I can't arrange a 2 megabyte of space. So I can put one and one another processes.
But if they are contiguous, we can take one by one, we add them.
Yes, it should be happen like that. Actually, in contiguous, it is easier because you don't need to just change the place. So in this case, you have to change the place of the location of the data. And this is not easy. And it will also take time. Do you understand what I'm saying? I mean, for example, you have to, for example, change the place of P1 and P3. For example, to make P3 and P1 to be contiguous, what we can do, you can, for example, take this one, put here, but while you are putting, you have to just put this data down. So this takes time. Okay. So to just avoid this, I mean, to make it better, they will try to just change this rule. I mean, if they are not contiguous, you can't put something there. They have to change this rule. Okay, I will continue. The next one is compaction. This is the better version of dynamic partitioning. So we got to know that dynamic partitioning suffers from external fragmentation. And this may cause serious problems. Okay, so what we can do, let me to read it. To use the compaction, we need to change the rule which says that the process can't be stored in the different places in the memory. So what it is saying, we can save the process into different places. Let's check what it is doing. We can also use compaction to minimize the probability of external fragmentation. We have, okay. So in compaction, all the free partitions are made contiguous. This is very important. So when they are free, it means that if these partitions, if the total size of the memory is that, and these are free now. So you have to just make them to just settle together. I mean, it will be something like that. Let's say this will be go upstairs, let's say, and the other two will be together. Okay. So we are actually doing what? We are separating the used spaces and unused spaces. So we are dividing them to other side. So in this case, we can store bigger processes. So let me to give an example. Okay. Think about that. Let's say this is 10 megabytes. And one process came with 3 megabytes. One process came with 3 megabytes. And one process came with 4 megabytes. So all of them are full. Then, let's say again the similar thing, or let me to make it 13 megabytes and give another. Let's say this one and this one finished execution, these two. So this is empty. This is empty. So normally I can't put something bigger than 3 megabytes here in these two places. Okay, but in compaction, in dynamic partition, in compaction, what I can do like that. I can just separate the empty spaces and full parts. So this is 3 megabytes. I mean, let's say this is process 1, 2, 3, 4. This is process 1. Okay. This is process 3, 4 megabytes. Okay. And the other 6 megabytes will be like that. Actually, it is 6 megabytes. It is 6 megabytes. Here I can put 4 megabytes of process, but here I can put 6 megabytes. Let's say process 5, 4 megabytes, let's say. I can put it there. Or 6 megabytes, I can put, okay? This is how compaction works. So compaction is just separating the empty places and the parts that processes are located. But this is also a very big disadvantage. Who can tell me? I actually just said a few minutes ago.
Changing place.
Yes. Continuously. Think about that in memory continuously, they are changing the places. And this will take, while the places are changing, processor cannot execute any process because the places are changing. So this is a very big disadvantage. So the free partitions are merged, so which can now be allocated according to the needs of the new processes. And this technique is also called defragmentation. I don't know if you ever did do defragmentation to your hard disk. Any of you? Computer disk is actually working in similar logic. I mean, while you are putting some data, deleting, actually there will be some empty spaces into your hard disk. And this will cause computer should trace more area to find something or to delete something. So you can make defragmentation, just separate the empty parts and the full parts. So it will increase the efficiency of the computer. So the problem, let me to explain this one as well. I will finish the lecture in just a few minutes. The efficiency of the system is decreased in case of compaction due to the fact that all the free spaces will be transferred from several places to a single place. So actually, while we are changing the places, we are changing the just data. So all of them needs some time. So despite of the fact that the compaction avoids external fragmentation, it makes system inefficient. So it will take so much time. Okay. So another calculation. Let me to, by the way, you can take the my daughter, 5 years old, she's not sleeping at night. Maybe I have to just teach her something. She will sleep. Okay, by the way, makeup will be next week, but this is university decision. Only the students that they didn't attend, they can come, okay? So last time some students tried to enter the exam. They attended, but they were trying to attend again, so don't do it. Okay, so here we are going to calculate how much time we need to transfer one data from one space to another space in memory. So let us consider that operating system needs 6 nanoseconds to copy 1 byte.
From one place to another.
Okay. So it means 1 byte of memory from one space to another space. It needs 6 nanoseconds. So if we need to transfer 256 megabytes, how much time we need? So
If one
we actually you have to make just the terms equal. Okay, so
1 byte takes 6 nanoseconds and 256 megabyte take how many nanoseconds?
okay, if one byte
1 byte
is 6 nanoseconds.
256. This is so
2036.
no wait.
But so
1 byte and megabyte, is it different?
yes.
Yeah, 1
So
byte.
you have to just in this way, in this way. Let's make it in bytes. It's easier to convert. So what is it? 256. What is mega?
Mega is 1,000.
Million. 10 to the power of 6 million. Okay. So 256 times 10 to the power of 6 multiply by 6 nanoseconds.
Yeah.
So if I am asking you in nanoseconds, you can keep it. But if I ask you how much seconds, I mean in seconds, it is giving the answer. So to convert this one to seconds,
10 to the power 9.
not 9, minus 9.
Minus 9. Decreasing.
Yes. Because nanosecond is much more smaller than seconds. So it should be negative power. So divide by 1. Okay, so
6, 36, 5, 6, 30. 6.
You have to multiply this number to me.
Plus 3.
256.
15, 1,536. 1,536. It's that.
Last phase.
1536. Yeah. Times minus 3.
Yes. Just when I'm multiplying the powers, I am subtracting.
Yeah.
Yes.
Now this one is 1.
I can change. Yes.
1.536. In nanosecond or second.
Yes. If you just make it like that, 10 to the power of 0 is 1. So this is second. Yes. So this here we are making conversion actually. So the main thing is, if I am asking you in nanoseconds, you have to convert to nanoseconds. So if I tell you convert it in nanoseconds, what you have to do?
This one multiplied by 10 to the power 9.
Yes.
This will be 1
nanoseconds. Okay, I'm not going to
1,530.
You want to just write everything?
No, just for this one, for the 3 zeros, to make it to power 6.
No, sorry. This is
1 point.
This is 1 point. I mean, in Turkish and English, it is just we are separating thousands by comma. That's why I missed. Sorry. This is decimal point. Okay. I will give you examples related to that. So, did you understand? Because yes, you got it. I understand. Okay. So, okay, we are actually doing what? It is given to us 1 megabyte of data needs 6 nanoseconds to transfer from one place to another place. So here we are saying that more data we put, it needs more time. Okay? So which we are trying to say in compaction, if we continuously try to change the places of the data inside the memory, we will waste too much time. Okay, so here 1 byte transfer needs 6 nanoseconds. How much time needs for 256 megabytes? But look, 1 byte, you can do it like that. You can multiply 256 by 6 and divide by 1. The units are different. Okay, this is megabyte. This is megabyte. This is byte. So you have to convert to one of them. Even you have to write it in megabytes, this one, or you have to write this one in bytes. That's why we use we choose to write it in bytes. So 256 megabyte is 256 million bytes. 1 megabyte is 1 million. So by using this, you can calculate. And also 6 nanoseconds. If I ask you to give me the answer in nanoseconds, you don't need to change this. Just write 6 here. But if I ask you to give the answer in seconds, so you have to convert this one to seconds. So this is nanoseconds. Look, for example, microsecond means 10 to the power of minus 3. Okay. Then what is it? Micro?
No, picosecond minus 6.
Pico is no. Pico, I think bigger.
Pico is down.
Is this anyway? So nano is 10 to the power of 9 minus 9 seconds. Smaller. I mean, like this. 1 centimeter. Look, 1 meter is how many centimeters?
1 meter centimeters.
100 centimeters. So 1 centimeter, how many meters?
10 to the power minus 2.
Yes, 0.01 meters. Yes, or you can say, and your friend said, 10 to the power of minus 2 meters. Okay, because of this one is smaller than meter, so we have to show it in a smaller value. Okay, I may give you some exercises. Maybe next time we can solve them in class as well. This bit-byte conversion is actually you should learn them not for this lecture, but in general, if you are going to be an engineer. Yes.
We have table for the conversion.
I can give you, I mean, 1 byte, megabyte, gigabyte, or times. Actually, you should know them, but okay, let me to give some exercises next time, and we can do it together. There are tables, but actually you have to know it. I don't know in maybe your education system is different. You may see something and we didn't see something. I don't know, but for example, in primary school and in the beginning of the middle school, in our education system, students are seeing these things. Not bit byte, but I mean the terms and the difference between them, the ratio. Okay, I will upload this lecture. Also, I don't know what I did. If I recorded the lecture, I will also upload as well. Because of I am alone, it didn't cut me in 40 minutes. Yes. Why I didn't? Yes. So I can do it infinite time.